What does it take to find a guest in a hotel? We might be given the floor, then the wing, then the room number. Finding the location of an electron in an atom is maybe not so different. This is Real Chem. Understanding the locations of electrons using different models is something I struggled with during college. It took a while before it clicked. The key for me was to break it down into some basic steps and not lose sight of the system I was using to find them. If you find this hard, don't worry, stay with it. Vamos a mirar juntos. Let's explore. Why do we switch between the Bohr model and the shell model of an atom? Well, it depends on what we're interested in. In our hotel analogy, locating an electron in an atom is like asking, where is a guest sleeping? The Bohr model would have to say they are sleeping on the 3rd floor. The shell model gives more detail, like room number and which side of the bed the electron is in. More advanced theories of electron structure give even more detail. In chemistry, choosing a model is all about the level of detail we need. The Bohr model gives us the least detail on the structure of an atom. It depicts electrons orbiting the nucleus in discrete quantized energy levels labeled with the principal quantum number n. It also captures that as n increases, the electrons get further from the nucleus and the energy of the level increases. However, the Bohr model formulas for energy and radius of an orbital apply only when there is a single electron in an atom, or ion. For atoms with 2 or more electrons, we need to move to the shell model. Unfortunately, we don't have a simple formula for the energy levels of a multi-electron atom. However, the shell model does tell us the pattern we should expect for these energy levels, and this pattern tells us a lot. It results from a set of quantum numbers assigned to each orbital in an atom. To help understand this, let's return to our analogy of locating a guest in a hotel. The principal quantum number is like the floor of the hotel. It is the n of the Bohr model and tells us the shell. Each shell has 1 or more subshells, which are like different wings of a hotel floor. They arise from the quantum number L, which describes the shape of the orbital. Within each subshell, there may be multiple energy levels. These arise from the quantum number ml, which describe the orientation of the orbital. Because orbitals with different ml only differ by orientation, all orbitals in a subshell have the same energy. Finally, each orbital in a subshell can hold up to 2 electrons. It is as if each room in our hotel has a double bed, and guests can sleep on either the left or the right side. The quantum numbers ms is similar, except instead of the left or right side of the bed, the electron can have either spin up or spin down, which we show using up and down arrows. Let's look at the potassium atom as an example. It has a total of 19 electrons. We start by filling the orbitals with the lowest energy and move up. Each energy level gets 2 electrons, one with spin up and one with spin down. When completed, we get 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. Finding your room in a big hotel might sound difficult. It is one of hundreds of rooms. But by following a simple system, the floor, the wing, the room number, and so on, you will always get there. Using the right technique, you can locate electrons just as easily. Vamos a explorar, y no se te olvida tener fun. So explore, and remember to have fun.